Oh, yay, it's going again. Now, I have a question. Cool? I'm going to erase them if that's okay with you guys. What I want you to do now is I want you to look at your data sheet. The next data set down, I think it does anyway. It involves, yes, ADHD, attention deficit hyperactivity disorder. I'm interested in this, obviously. and brain volume of kids without ADHD. Brain volume, so size of brain. For years, I've heard claims that Einstein, for example, had a larger brain than average. There's a book, actually. What the hell was that book called? Some dudes took Einstein's brain for a car ride across the country. It's like in a jar of formaldehyde in Princeton, and they took it for some reason across the country in a car. And one of the, what's that? I don't remember. I don't think it was legal. But anyway,
Stolen Einstein's brain.
Stolen Einstein's brain's a song in that somewhere. But the idea of brain volume, we're interested in brain volume and seeing if there's any kind of correlation. I love studies like this. I want to collect some data on this one. Just recently, I heard that there's a spike in MS in some Middle Eastern countries since the revolutions of 1976 to 1977 when the dress changed. So when women were forced to wear full head and body covers, MS rates have gone through the roof, and they're suspecting there's a tie between vitamin D deficiency and MS rates because you're not getting the sunlight anymore. So I love studies like this where you're looking, not that I love MS or things like that, but I love looking for, that's what statistics is all about, trying to see if there are differences tied to certain third party, if you will, characteristics. Yeah, Mike.
I've taken a look at some of these studies
before. Oh, okay.
And one of them that I looked at specifically showed a brain shrinkage. But the thing is that they were actually measuring kids who were on Ritalin, and Ritalin was causing the brain shrinkage.
So in other words, it was all ADHD kids and the medicines they were on.
Yep.
I've got a data set coming for that one too.
Okay.
Ritalin versus Adderall versus dosages of each.
Well, and it's some of those are meth essentially, and the meth causes that as
it's pretty amazing if you think about it. I found that out in the past couple of years that like Adderall and Ritalin are actually stimulants, which is kind of crazy to think about. That's to knock ADHD down and put the stimulant to do it. So we're going to analyze that a little later. But the thing is, actually, let me go back to like 5 minutes because it ties in beautifully to this. It ties in beautifully to what we're talking about right now. Okay. How is this data different than the data we've just gotten done looking at? Both data sets we just looked at. We both looked at the difference between thumb and forefinger size, and we looked at the difference between thumb and forefinger times, and we looked at the difference between commercial and show volumes. How is this different?
Not the raw data.
Oh, very good, Ashley. I wasn't thinking about that. That's 100% correct. It's not raw data. This is called summary statistical data. This is all you can get, unfortunately, sometimes from these studies. When you guys actually go and consume journals, a lot of times they'll just give you these summary statistics. Very nice. I wasn't thinking about that. Perfect, though. How else is it different? They give you averages, which is part of the summary statistic part. You're right, Susie. And in all honesty, I could give you, I won't do this, just so you know, but I could, for the previous problem, have given you the summary statistics from the differences. In other words, X bar 0.12, S, whatever it was, and N equals 24, and have you run the t-test that way. But I won't do that, because I like you to see the actual raw data, because I want you to actually make the call about how to subtract it. Good. What's the big difference contextually? You guys both nailed the idea of the presentation of the data, but the data itself, is this a matched pair study? Say that again, Zoe. Oh, we got ourselves independence of the two data sets. We have got kids with ADHD, and over here we got kids without. There is no link between them at all, assuming they've been diagnosed correctly. And this goes back to research methods classes that you guys keep asking questions about, which is fantastic. This is very different. This is very different. Think about with the thumb and the forefinger. There was a linkage between your thumb and your forefinger, your brain controlling them. There's a link right there. Think of the link between the show and the commercial volume levels. The link right there is the actual presentation of which commercial, which is based on contextual differences at oral levels. There is no link between the kids that have ADHD and the kids that don't. They're independent populations, if you will. Even if they weren't, could you pair them off? Even if they weren't, could you pair them off? How come, Darla?
Because you have two different samples.
You have 152 ADHD kids and 139 non-ADHD kids. So even if you wanted to pair them off, you couldn't. And you can't do it anyway because you don't have the raw data, as Ashley and Susie pointed out. Go ahead, Michael.
The only way truly to pair them off is if you had like identical twins.
True, very true. And I think we'd be actually looking at a different research study at that point.
For sure.
You're right, though. You're right, exactly. There has to be some kind of a link between the data sets. So I want to do a recap real quick. I want to put it on the side board so we can leave it up. Where we're headed with this data set, it's a slight shift. So we have here hypothesis testing. It's going to look a lot like the previous. You might just want to add to the previous one that you have in your notes. Single parameter. Single parameter. We had P. In other words, looking for a single proportion. And we had mu, where we're looking for a single average. And the single average, as a subset of that, has that matched pair hypothesis testing. Okay, that's all. Every single one of those deals with a single parameter measure. We didn't break it down to the average of the commercials minus the average of the shows, because we weren't interested in that. We were interested in the average difference between the shows and the commercials. This is definitely a difference of two unique averages, isn't it? It's the average brain volume of ADHD kids and the average brain volume of non-ADHD kids. So now we have to actually have a new arrow, don't we? And what's that new arrow box going to be? What do you think? Good! Two independent parameters. Yeah, these are single parameters, which by definition, since they're single, they're independent. We now need two independent. I love that word independent too, thank you. Two independent parameters. Heck yeah. And we're going to have two different kinds of these. Why two? Think back to single parameters. What kind of parameters were we measuring back in the day? Back in the day, as in 5 minutes ago. Say that again. Carrie, go ahead.
I don't know.
Yes, you do.
One-sided?
Good. One-sided confidence intervals on an average or on a... Look over here. Exactly. So we're going to have the same split here that we did here. Now, I'm going to put them in the same order as they were over here. Although I don't think we'll get to this one today. We're going to have P1 and P2, which will be two different proportions. A first proportion and a second proportion. I don't think we'll get to that one today. As a matter of fact, I guarantee we won't. We won't have time to get to it today. I don't want to get to it today anyway. That's rushing to get it in. We'll get it on Thursday. Today we're going to look at mu1 and mu2. Yeah. That's what we want to look at. That's what we want to look at today. And then next week, and we're going to wrap up the course with this, we'll have one more arrow off of hypothesis tests for 3 or more. Michael, what you said about the Adderall and the Ritalin, the data I found deals with Ritalin at 15 milligrams, Ritalin at 30, Adderall at 15, Adderall at 30, and a control group. That's 5 different averages. 5 different averages score performances on a test.
Yep.
So you have to have another category when you have more than 2.
Well, and the interesting thing was that the studies that I read were actually in scientific journals. And
Absolutely. I would hope they would be.
Well, yeah, they were all, tested and obviously approved.
Yes.
By,
Absolutely.
all of that. But the funny thing was the initial test is what spurned all the other tests, because the initial test was like ADHD kids have 10% smaller brains.
Right, exactly.
And then everybody else looks at the
Wait
data
a
and
minute.
goes, no.
Wait, exactly. But you bring up a very good point, because every time we run a test, we could be wrong. Right? Which means the one that said ADHD kids have smaller brains and then was recounted by other tests was just one of the 1%. 5%. Was just one of the 5% type A's. That happened. I think I told you guys this in the New Yorker magazine about a year ago. It's in the Stat of the Day journal, which I know I've kind of fallen off updating this term. There was an article called The Truth Wears Out or The Truth Wears Thin, talking about all these scientific studies that have been overturned. And they list about 17 or 18 over the course of 5 years. I'm thinking to myself, of course that's going to happen. Think about the hundreds, if not thousands, of papers that are published every year. Of those, 1 in 20 are going to be false positives. On average, you guys proved that in your last project. So it's not that the truth wears thin, it's that the truth becomes validated through multiple testing. No, it's a great point. So let's look at one of the studies that does just that, shall we? This one right here? Yeah, that's good. So let's come over here. This thing is having a hell of a time staying centered. There we go. Let's answer. Yay. Let's answer the question, or let's test the question. Do ADHD kids seem to have smaller brain volume? ADHD kids, smaller brains? I don't know. Let's see. See if they do. Now we have to have two variables now. We have to have two variables. mu1 and mu2. Which one do you want to be which? What's mu1 going to be? What do you think? Which of the two kids?
Without ADHD?
Wait. I heard you say both.
First one, ADHD.
ADHD is the first one? Okay. So this is the average brain volume for ADHD kids. And this guy here is going to be the average brain volume for the control group. Remember that word? Yes. I love this. I love this because now you actually get the idea of a control group to come back. You actually have a group that's being measured as a control group. Okay. What do you think? How can we test this using tools we already have? How can we test this using tools we already have? What do you think? To see if there's a difference or see if one's smaller than the other. What do you think? What do you think? Give me some ideas. We have tools. We do. I'm not saying they're the best tools. There's a more refined tool, but what are the tools we have right now? Could we run a t-test? Let me ask that. Could we run a t-test? Let's take a look. Let's just grab the TIs. Bob, go ahead.
I got a question.
Yes, please.
So the control group is not the non-ADHD?
It is. It's a non-ADHD. It's
So you're
whoever's
just saying,
right. The only variable you're measuring, well, the variable you're measuring is brain volume, but the control doesn't have the condition of ADHD.
so,
Go ahead.
so I got one more.
Yeah, go ahead.
Are they on any drugs? Like
This is regardless of drugs, and I would hope, in light of what Michael said and what you're implying, that whatever that is being controlled for in the study, which means all the kids are identical in the experimental group, except that they have ADHD and the kids in the control group don't. I would hope. I don't have that.
Because the drugs could shrink it.
As Michael just said, exactly. And I would hope that it was controlled for, again. I try to pull this stuff out of scientifically refereed journals, or actually peer-reviewed refereed scientific journals. Cool? Friends, grab your t-test and take a look. Stat, test, t-test. Here's your input screen. Now, technically speaking, we can't use this input screen because we don't have raw data. We have statistics. So I'm going to scroll over to statistics and press enter and take a look at this. And notice what it does. It backfills with the last thing that we did. This was the commercial data slapped in here. So you can tell on average there was about a 0.4 decimal difference in the volumes and blah, 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 blah. And that's fine. Can we use this to test our ADHD values?
Yeah.
Tell me how.
Well, we have N.
We do have N,
And we have X bar.
and we have X bar,
And we would put S in.
and we have S. We've got everything we need. So what are we going to put here? What's going to go here, here, and here?
Well, X bar is going to be
Let's see what we got here.
1,059.
So, okay, let's do this. So we got X bar is 1,059.4. Okay, there we go. S is going to be 117.5, right? N is going to be the 102 kids that did it. Cool? Okay, what else has to go where?
Let's get ADHD.
These are the ADHD kids' results, right?
Right.
We want to see if the brain volume.
What goes there? It's not 0, right?
1104.5,
Why 1104.5?
because that's the brain volume of the non-ADHD kids.
Jared brings up a very, very good point I want to reiterate. Jared is saying 1104.5 here, because that's the average of the non-ADHD kids. I agree, except for the fact that that's the average of the non-ADHD kids where? Say that again. In the control group, which is a what and not a what? It's a sample, not a population. So we shouldn't do that. I love what you said, Jared. If they told us that the average brain volume of of non-ADHD kids is 1,100 milliliters. This would not be this. We would then know what this is already, and it would simply be a t-test. We put 1,100 up there and call it a day. Fair enough?
So it would be no end value on that.
It would be infinite if you would, or basically the entire population with a zero margin of error. That's the problem with running a simple t-test. E, what's on your mind back there?
Oh, I was just gonna say, would it be a two-step Z or T?
Good. The problem is we cannot do a single t-test on this. We can't, because we have two different samples. We don't just have one sample anymore. This is actually two different samples. Now, one thing we could do is we could run two different t intervals. From back in the day, we could run a confidence interval around the ADHD kids' brains and a confidence interval around the non-ADHD kids' brains and compare the confidence intervals. What's the problem with that? As is always the problem with that.
Well, I don't know what the problem is, but it's a two-sample t-test.
We're getting there. Yes, it is. You guys have nailed it. What's the problem with that?
Margin of error?
The margin of error is basically misleading because you're looking for a one-sided test, not a two-sided test. And what do you sacrifice when you run consistent intervals over one after the other, after the other, after the other? You sacrifice confidence. We need one measure. Yeah, Gary Price. We need one measure. We need one measure, one test. And you guys have already found it. If you look at the stat tests menu, and you go down and you see this guy right here, he's 2 under t-test, 2 sample t-test. That's the one you want to use. That's the one you want to use. Not Z. Not Z tests. How come?
Because this is an average.
Because we're testing an average. It's a measurement. Also, if you look at the 2 sample Z test, notice what it tells you to put in. Sigma. You don't know what sigma is. That's the population standard deviation. If you knew what the population standard deviation was, you know what the population average was, and you wouldn't be doing statistics. You'd be doing parameters. That's silly. Yeah, Ashley.
I was going to ask that because on my t-test,
Yes.
it did have little sigma. It didn't have SS.
That means you hit Z, not T.
Oh, okay.
Yeah, any time, if you're looking through your stat tests menus, you will never ever use anything with a Z unless it also has the 4 letters prop with it. The only time you're using a Z is if it's a proportional Z. That's the only time. So you're never going to use a Z test, never going to use the 2 sample Z test. You are going to use these guys. We've already used him, we're going to use him on Thursday. Z interval, Never use a Z interval, use the T interval. So you have to look for the word prop with Z. And then you'll know everything's copacetic because it's not asking you for sigma. Cool? 2 sample t-test. Why does this make us happy, friends? Because we have everything we need. I do think we got a little ahead of ourselves, though. Let's put some hypotheses up here, shall we? Yes? I think? Yes? Let's get some hypotheses on the board. We're actually going to tests. What are we testing? What are we trying to see? If brains are smaller, right? Brain ADHD. If they're small, shrink. Maybe shrink. So what's going to be in the null, do you think?
U1 is smaller than U2.
I believe that's going to be in the research. What's going to be in the null, though? That there is no difference between. Actually, you know what, Mary? Let's put the research down first. Let's put the research down first. The research is that U1 is less than U2. I like that. It's often a good idea to put the research, what you're trying to test, in H1. Then you know what the null is going to look like. And you know what? If you want, you can probably just leave the null blank, for that matter. Once you know what you have to test, the null is whatever's left over. Yes? We're trying to see if ADHD kids have smaller brains than non-ADHD kids.
Can we just spell in and all?
Oh, of course. I'm not saying don't, Lindsay. I'm saying once you have this is what you're testing. So yeah, for sure. For sure.
Yeah.
Anybody putting greater than or equal to? That's fine too. That's fine too. The data will tell us whether or not, remember, just like on your take-home exam, maybe they're not only smaller, but they're significantly larger. That's possible. That's possible. But the data will tell us that. The data will tell us if there's a difference and what direction the difference is. Fair? Lindsay, is that fair?
Yeah.
Good. Now we need a test statistic. We need a p-value. What's that test statistic going to be? What variable is it going to have? It's going to be t. It's going to be t. Absolutely. All we've got to do is get our data into this thing in a succinct way and keep track of what the data are. So I know we have called mu1 the ADHD kids. So we're going to go x bar 1 is 1059.4. with a sample standard deviation of 117.5 and a sample size of 152. Beautiful. X bar 2 is 1104.5 milliliters, plus or minus 111.3 with a sample size of 139. Some of you might look at that and say, my God, there's no difference at all between these two. I mean, when you have sample standard deviations as large as these are, and you look at how far apart these are, there's complete and total overlap. And that's correct when you're looking at it from a descriptive statistical point of view. But with a sample size of 150, 140, what happens to your curves? Shoot, shoot. Which means, yeah, they're only 50 milliliters apart, but as soon as you adjust this guy with this guy, with the central limit theorem, there might be a difference. And that's what the test does for us. The test draws the curves for us beautifully. But it draws one curve. I want to finish the class with the discussion of what that one curve is. Okay, we're testing less than, correct? Yep. And Lynn, not that I don't think it's a good idea to have the null in there, but this is why I say you can stop with the research, because that's all you need to enter. Make sure the TIs look in the correct place. Paris, go ahead.
My calculator looks kind of different when I do two samples
What?
or t-tests.
What's it ask? Oh, make sure you're in stats, not data. The very first line says stats and data. Make sure you're over on stats. Yeah, data, you'd actually have to have lists of data, which we'll play with on Thursday. That's the next data set I have for you, the Core Plus math curriculum. Fair enough? One little goofy thing at the bottom, friends. There's a little thing that says pooled. I want to mention this in a second. I'm going to give you a wrap up here after we run this test. But always leave that on note, and I'll explain why momentarily. I'll explain why momentarily when we talk about what is actually going on with this number right here. I want to explain why you leave pooled on no. It's a kind of an antiquated thing that probably shouldn't even be there anymore. We'll come back to it. Ready? Let's draw it. Here we go. Hang on. Let me just turn these things off. It's driving me nuts. There we go. There we go. Now I'm happy. Okay. It's a left-tailed test. If there was any area, I should have seen it by now. It should be over there. I don't see any area, and there's why. There's not a whole lot of area to see. Does it look like P is basically 0, isn't it? 0.0004. Does it look like ADHD kids have smaller brains than non-ADHD kids?
Yes.
It does. It does. This curve is the non-ADHD kid's brain volume, right? Essentially. Take that back. This curve represents the difference, if you will, between ADHD and non-ADHD kids. A 0 would indicate there is no difference. We landed, we landed down here, negative 3.36, which makes me think that we don't belong on that curve. And that curve is, if you will, the 0 difference curve, which implies to me that there is a difference. Go ahead, Christian.
If there was not a difference, would we see, does the shade represent overlap?
The shade, essentially yes. The shade represents overlap. And above 5% of shade represents significant overlap.
Okay.
Yeah, that's exactly right. Looking at that sign, you can tell where the shade should be. Left tail, there is shading down here. It's way out here. And the pixels are so 1984 on this thing that you can't see it. But yes, there is shade. It's just very, very, very little shade, which means there's high significance to imply that that's going on. Now, I want you to understand what that 0 stands for, because there are two different data sets here. There's a data set for the ADHD kids and a data set for the non-ADHD kids. And I know when I had you guys understanding the idea of overlap, we actually had two different curves. And I do believe that's what's going on. There is a curve for ADHD kid brain volumes, and there's a curve for non-ADHD kid brain volumes. I'm saying this agrees with that belief, that it looks like that ADHD kids have smaller brains. What I'm saying is you don't want to test it by slapping a second curve up. You want to test it by using one data set and one curve. So what I want to do real quick, I'm going to slide over here. I want to give you the mathematics briefly, very briefly, behind what test statistic is being used, and also that pooled thing to explain to you why it's no, why you leave it on no. Write this down only if you're interested in the mathematics of the test. No. I'm not. Otherwise, just kind of let it wash over you. Go ahead, Lindsay.
Quick question.
Yes,
I
please.
know we just did it, but what was the name of this function?
Two-SAMP-T test. We'll do it again on Thursday, I promise you that. Two-SAMP-T test. Now, a z-score, as you remember from back in the day, a z-score, you have your data minus your assumed average over your standard deviation. This is what we were doing just about at this time last term in 243. Just about. We're talking about the shower head heights in Bishop, California hotel rooms and all kinds of other things like that. When we adjusted it for inferential statistics in this course, it changed slightly. The z-score then dealt with the population's, the sample average, not just the sample data point, minus mu, over the sample standard deviation over root n. Essentially, that's the new inferential version of the descriptive version up here. Okay, and honestly, we've been calling this guy T, because we're dealing with averages, not proportions.